Hi, this is the video for the second question from the review exercises for the end of the semester. So at a particular college, the number of tattoos that individual students have follows a Poisson distribution. So calling X the number of tattoos is Poisson. And that means is that the probability that our number of tattoos takes on a particular value, little x, is equal to lambda to the x times e to the minus lambda over x factorial, and that is for x equals 0, 1, 2, and so on. And we are told that the number of students who have no tattoos, the probability of no tattoos, is 3 times the number who have 1 tattoo. So 3 times 1. And so I can use my probability mass function and say, okay, this means that lambda to the 0 times e to the minus lambda over 0 factorial equals 3 times lambda to the first power times e to the minus lambda over 1 factorial. And I can solve this, and if I do, I find that lambda is equal to 1/3. So first of all, the question here is, what is the average number of tattoos among students at this college? And so remember that the expected value of x, when x is a Poisson, is equal to lambda, so that's just equal to 1/3. Now for part B, we want to know the standard deviation for the number of tattoos. And if you recall, the variance of a Poisson random variable is equal to lambda, so the variance is 1/3, which means that the standard deviation, sigma, is equal to the square root of 1/3. So there's the first 2 parts. Now, part C asks, what is the probability that a randomly selected student has 2 or more tattoos? So the probability that x is greater than or equal to 2. This is easiest to find using the complement. That's 1 minus the probability that x is less than or equal to 1. And I can either use my Poisson CDF, or I can use my probability mass function evaluated at f0 plus f of 1. Regardless of how I do this, I should come out with 0.0446. And then for part D, our last part here, suppose that a random sample of n equals 50 students are selected from the students at this college. What is the probability that the sample mean is more than 1/2? So here we're going to use the central limit theorem, which tells us that the sample mean will have an approximately normal distribution, as long as the sample size isn't too small, and 50 is not too small. The mean of that normal distribution will be at the mean of our population, so that's going to be at 1/3. And the variance is going to be at the variance that in the distribution, so 1/3, divided by the sample size of 50, so that's 1 over 150 is our variance. So now to find the probability that the sample mean, x bar, is more than 1/2, I can either use my normal CDF with this mean and variance, or I can standardize and find the probability that z is greater than the standardized value, 0.5 minus 1/3 divided by the square root, because I'm looking for the standard deviation here, of 1 over 150. And that's the probability that a standard normal takes a value greater than approximately 2.04, which is around 0.0206. And there's our second problem.